Hello everyone, welcome back to Livestream. This Livestream about software development, front end. This is the second session. We started a week ago with the basic scaffolding of our project. Today we are going to evolve that project even more, bring that to the next level, trying to integrate with some REST APIs and evolve those concepts. This entire live stream series probably will also cover other topics and other things later after Isomorphic complete. I already have some ideas of other topics to cover. Again, my name is Lucas. I have been working in front-end development for more than 10 years. And my intention with the live stream is to share a bit of everything I saw while doing working in the front-end side. I hope that's valuable to people. And my intention is to cover always from the very basic level, having some content available to people who want to join the front-end development and want to understand more how things work. Uh, I think we should today we should be able to complete the topic for our isomorphic. The idea is we are going to improve the application, including some type of state management, transferring that state from the server to the browser, also using that state in the browser rendering in the hydration process. And we will also try to improve how our URL, the URL of the application is getting processed, having some query parameters, having some evolution. That part will be good. And in the end, we also could make the appearance of this application slightly better, because that's a very, very basic HTML. The application looks really, really simplistic for now. If you missed the previous live stream, you probably saw you didn't know how that application looked like, but I will cover everything that we did last week. After the live stream, you can go back to the original video from last week and watch that will make more sense, everything we are going to do. But I wanted to give a high level overview on the things that we did last week. Also, if we are able to finish the isomorphic topics today, my intention is to start a new topic for next week, or maybe we may skip one weekend and start the next one. In the topics that I would like to start, that will be a new sequence of live streams, maybe 2, 3, or 4, is related to security. So we can go into all the HTTP headers that are available, how they work, why you want to use them, and maybe trying to get a very high score in the security check tools. There is a very interesting tool from Mozilla, the Observatory, and we can try to create an application that scores the maximum in that tool, and how everything that we needed to do to have that score in a most realistic as possible application. I think that will be also a very interesting topic. Security is one of the main topics in my mind, because it's the parts that normally would differentiate from a intermediate front-end developer to a really senior front-end developer, is a deep understanding on how those security topics work. Also, interesting as a housekeeping things, I created a video playlist on YouTube where all the live streams are going to be there. And I will link if you are watching this offline, I'll try to link the isomorphic playlist somewhere in the corners. I also created a cropped version of the original live stream from last week. So there is a shorter video that focus only in the content, not in the chatting part and everything. So that should be a very interesting version of the video to share. I will do the same for this video from today, and probably we may even create a single video later with everything in a single video that you can have the entire content to watch all at once. Also, I think let me give a quick round in the platforms I'm streaming. Last week, for some reason, the Twitch was not working very well. Later, after the stream, Twitch had the video, so the stream worked, but people are not actually able to watch the live stream from Twitch. And I think the same problem is happening today again. So unfortunately, Twitch people are not going to be able to watch, but I see, look like all the other platforms are working okay and should be fine. The main placement for the videos later, like long term, will be YouTube. So if you want to watch and comment those videos, probably YouTube, you will have those things long term. The other platforms are more like to have more people watching randomly if they can find the videos there. Don't have a very good discoverability, but should be interesting to have in as many platforms as possible. Let me see if there is any other topics. If you didn't watch the first live stream last weekend, the idea is the very first part of the live stream, maybe the first 5 to 10 minutes, we go over like a context and announcements and this type of general conversation. I normally jump into the main topic of the live stream after some minutes, so you still have some time if you wanted to share the link with your friends, co-workers, anyone who may get value from this type of content. I'm not jumping into the content immediately yet. And I also keep some time in the end where we can talk about anything else, even non-technical part. If you have any topics you wanted to chat, you wanted to discuss games or anything else, that type of time in the end should be a nice moment to have any other topics. I also got a very good feedback from people watching from last weekend. Some ideas, trying to make the videos better. I'm probably streaming in a higher quality today. Like yes, last weekend I was streaming in 780, 720p. Today should be a slightly better quality, so you should be able to read the code in the screen better. Also, audio is probably going to be better. I applied some processing in the audio, so less of my environment noise should be going through the microphone. And yeah, I think that's a very interesting learning. I'm expanding my expertises on streaming video and quality of audio and everything. That's a very nice area to know more about. And if you have more feedback about the streams or the how I could be doing this better, please let me know. Write the comments or email me, add me on LinkedIn, and we can have like some nice conversation on that. I'm also expanding my understanding on video editing. The video I created about the cropped version, I created myself with like the simplest editing software possible. Anyone with video editing skills will judge that very a lot, but I'm learning, and if you have a comment on ways that I can do that video editing better, also let me know. I'm happy to improve on that. Let me see. I think we should be able to start going into more related to the topics for today. As you can see, we stopped the project exactly in the same place where we finished last week. I pushed this code to GitHub, so now you should be able to see in the description the link for GitHub. If you wanted to pull that code and run in your own computer, that should be easy. Also, I only changed one line of code before sending to GitHub, and you may remember from last week we were having like some error messages when the browser was trying to load the favorite icon, and the favorite icon was not available. So the idea now is that I included a single line of code here that is basically a way to tell the browser like, don't worry about that favorite icon. And from now on, we should have less of those error messages. When I was watching the live stream again after, I saw that there was a moment where I ran the application and a log appeared in the console twice. And probably if you were watching, that sounds a bit weird, like why that log appeared twice. And the second time was because the browser was trying to load the favorite icon, and that was generating the same log again. So that was part like if I'm when I created the edited version of this video, I try to include that moment of the first live stream, and that will make sense why that appeared twice. But with this line of code, then that error message should be eliminated. Let's go into a very high-level overview of what we did last week, and that should be easy. If you didn't watch the original live stream, that should be interesting to understand. So we are covering isomorphic applications. So the concept of isomorphic we are related to running some code in the front end and in the back end. And we are trying to get the best of both when talking about the performance of the page. So server-side rendered application tends to be really good in the first content to load to the people. So that's unbeatable. Like if you have a server-side rendered page, the content will be on people's browsers faster, because the very first message you send to the browser already contains some meaningful content for them to see. In the other hand, single page applications, they tend to have a better experience after you finish loading the application and you are navigating and you are going from page to page and you are interacting with the application. Single page applications tend to be really good on that, because everything is already loaded in the browser and you only download some very small fragments of data. The isomorphic pages that we are building here is basically the best of both, where we have some content running as server side and also running as browser side. And that's why, as you can see here in my project, I have a source folder, and that I split in 3 different areas: server, client, and common. And the server and client work as entry points for those 2 environments, for the server side Node.js and for the client side browser. And they translated those internal APIs of those environments to a more generic API where our common components exist. So our common components, they will never know exactly which environment they are running. They only receive parameters, to the minimum number of parameters that they need to execute the content that they need. And that code will be encapsulated in both executions. So we run them in the server side to have a server side rendered page. And we will also bundle them as part of the JavaScript bundle, so we can always recreate them and rerun that rendering process in the browser. Here, this file that is open right now is the entry point for the server side. As you can see, we started extracting the path name from the request object, and we are using that path name to execute our root component. And then the root component doesn't need to know where that path name comes from. That's a very interesting, because that's basically the same that the entry point for the browser is also doing, is extracting the path name from the environment, in this case using the document location, not the request, and is providing that path name to the root component exactly in the same way. So with those 2 entry points providing the path name, the root component doesn't really need to know where the path name comes from. And that's how we achieve agnostic execution of this component. This component doesn't need to know if it's Node or browser, only needs to run based on the path name. So that's the entire structure. We built this in the first live stream. If you have some questions later after we finish here, go back, watch the original live stream. That's going to be very good. Probably will answer most of the questions you may have. And today we are going to have to cover those topics about especially the state and trying to integrate with this with some API. There is a progression to get there. Like, we will need to improve our entry points first, create some extra features, and then we can have that state. And I think the first feature we will need to create here is the possibility of parsing the query string. The query string has like a key value pairs where you have some parameters to send it to the application, and those parameters will change how the application is going to behave, whatever you want to do. And being able to extract those parameters and having them available as we re-render the application will be very valuable. Also, the concept of a state, we want to cover that. I prepared some diagrams. I will write them in the board later to explain exactly what we are going to do and why that tends to be complicated. But one of the interesting things is this concept of state and transfer state is one of the parts that I believe is the most complicated when we are talking about isomorphic applications. All frameworks that support server-side render, like React and Angular, they have some transfer state engine. Even Angular, they have like a service called transfer state service. And in React, you probably would extract your Redux state and try to make that Redux state available to the front end. So when you hydrate, you can pre-inject that state in the Redux instance running in the browser. That's going to make sense more as we go into the code. Don't worry about that yet. A lot of the things I'm going to create here is inspired in React and how React works, but they are applicable in other frameworks as well. Let me, before we jump now into real coding, let's have a look. There is even more people joining. That's good. Facebook, there are a couple of people, and yes, that looks good. Let's see. Okay, we can start now trying to understand a little bit more of that transfer state. And I think now is where I call, like, we started the content for today. Let me set up my camera a little bit bigger and we can go over that that explanation. So last week we covered like how the application would work. Like we had the entire flow where we run some code in the server, and then that server will run that code internally and will generate some kind of HTML page, and that HTML page is sent to the client. The client will render that page to the user, and as that page finishes displaying to the user, the client tries to internally execute the same code that was executed in the server and tries to reset that appearance to the user. So basically, the client is trying to generate a visualization that is identical to the visualization that the server created. Let's give us an example. So imagine we have a page. Our page has a menu, A, B, C, and some content. This could be generated by the server, and the server will send this data to the browser. But when the browser runs again, they will try to create exactly the same rendering, pixel by pixel, exactly in the same positions. And then the browser will try to replace the one that came from the server and inject a new version. We covered that last week on why that is important, because the client may be able to inject extra bindings to the page to make the page more responsive and make that interactive. So that's why we end up creating a representation that is identical to the server side, but with those extra bindings. The main problem is if the server had some kind of data available to the server to generate this page, that data will need to be available to the browser to create exactly the same representation. One example, imagine we have an API call where this list that we generate here is coming from a database, for example. We have names of users that come from a database, and if the list of names is not visible to the browser will not have that list, and the list will be empty and have no data to display. So that's what we are talking about. So if the server has any data that was used to generate this page, that data will also need to be available to the client, so the client can use that and generate the page identical to the way that was built from the front. That's the part of this part is what we are calling the state, and making this object available to the client is what we are calling as transfer state. So we need to make that state available to the client so that the original rendering of the page in the client side is really identical, and when we swap that content to the browser render, there is no flickering, like the user will not really realize, like the page is there exactly the same, suddenly it becomes interactive. That's what we are trying to accomplish by having this data available to the user. It is possible that instead of having the transfer state, you would rely on the client doing an API call to retrieve exactly the same content. Imagine a scenario as the server calls an API or an external API, and you can make the client also call that external API and retrieve the same content. So both would rely on the external API to build that data internally. That would work fine. But the problem is the time to the page to become interactive would be longer because the user would need to see the server-side rendered version of the page longer until that API finish loading, and then the hydration process would be able to complete and make the page interactive. So if we can eliminate this type of API dependency, our page can be interactive earlier, and then the time where the server-side rendered will be visible to the user could be shorter. That tends to deliver a better user experience to people if you can eliminate as many dependencies you can, like this API. That's why instead of relying on the client doing that API call again, it's more common to embed that JSON as part of the page itself, and then as the browser executes, then the data is already there, and we can generate that visualization exactly the same as the server side. I hope that was kind of a good high level. I definitely see that will make more sense as we go into the code. But yeah, let's start going and making this happen. That's going to be very interesting. Let me go to my corner again. So, as I said, to achieve this state in the transfer state part, there is a progression that we will need to evolve. And I believe that the first thing we will need to improve in our application is how we handle query parameters. So, what I mean by that. So imagine we have our application here. We can go, for example, if you see in the URL, we have like that page 1, and we could send messages like a test equal 1 2 3 blah blah blah. So you see that key value pair that we have we can send it to the server, and if we are able to process that query parameter and make that data available to our component execution, that would already be the very first representation of some kind of state. Like it is possible to almost reduce the need of a real state in the application by having the query parameters being the representation of the state. For certain scenarios where we are consuming from external APIs or reading from a database, that's not applicable. But for simple applications, and that's what we are going to start here, that is actually possible. So what I wanted to try first is somehow having a counter where I have a page with a plus button, minus button, and as I click on them, I can increase or decrease a counter. And this is something that doesn't necessarily need a single state in the application. The URL would be a good representation of that. I think that would be a good way to start. Let's start by running the application again. A week I didn't run this, but we should be able to build and start. That should be that's where we stopped last week, and our application should still be working exactly the same. But as you can see, we now don't have that network call for the favorite icon, and we can still navigate between pages. This navigation is happening as a single page application navigation, and I think that's good. Let me see. I think there is some weird blurry thing here in my chroma key. Let me quickly try to fix that, because otherwise that will be very distracting. Just a second. Should it be... Yep, I should be... Interesting. Let's doing some maintenance live. Yes. Okay. So that yes, that should be easier. Oh, now my microphone is even worse. Yeah, shouldn't have touched that. Let me quick fix that. That's the problem of being live on certain things. Maybe here. Now I totally disappear. Yep. Yes. Okay, that should be good enough for now, and we can continue in the topic. Sorry, diverging the attention, but should be good to continue now. So as I said, we have our application. Our application is working. We are running the same code in the server side and browser side. As I navigate here in the browser, this is happening as a single page application. But if I force a reload of the page, I'm actually calling the server in a specific path, and I am processing that page in the server side. So this is I am able to do that in both. Executed that code in both pages. So that is how isomorphic work. And if you see here in our application, we have here in the entry point the moment where we are parsing the URL. So here is the moment where we receive this entire URL from the browser, including potentially some parameters. So imagine we have this like test 1, 2, 3. So this entire URL is what we receive here as part of this request.url. And we are using the native Node.js parser to give us only the path. But the Node.js has an option where if I provide a second parameter true here, you can see here, TypeScript is telling me parse query string true. And now I am able to also use the query object. So the query object will tell me all those parameters and everything that is available to run. So I could now, with that query object, I could make that query available to my browser, to my component, sorry. And with that available to my component, then depending on what is there, the component may render one thing or another thing that. So here, what we will need to do, as I'm providing a new parameter, I will need to make that parameter visible here. And that is type any, because I don't really know what is going to appear there. And what we can do here, I'll try to display that that element. I'll try to display it in the page, so we will be able to see if it's working or not. So I'll receive the query. Query can be anything, any key value object, and let's display as part of the page. As I changed the signature of this method here, I will also need to provide that query string to the component in the browser. So let's see here how that goes. So you will see this root component is already complained that we don't have a query to use. And unfortunately, there is no native way to process the query string in the browser side. So what I'm going to do is I'm going to write like a very, very small function that is like a naive query string parser here, only for the context of this example. Just a sec. Yeah, sorry, I'm coughing a little bit. So I'm going to write that query string parser as a very, very simple query string thing here, only for the project. But in a real project, you can install libraries like to do that for you, and those libraries should follow the RFC definitions and everything. So here is again a very, very naive implementation, only to have the project moving forward, but without breaking the rule of no libraries. So here I'll have like a query ts that is going to be a simple query string, query parser. So I will receive some kind of query string. I'm calling query string because after I parse, I will create the final variable we call the query. And normally you should be able to do a lot of processing, like parameter names can be repeated in the query string, and then they should be treated as an array of values. There are some considerations to do. I'm going to do the simplest way possible, where I'm considering that parameters are only going to appear once, and I only have that as a key value. That will be simpler to deal with, but I know this is not the normal scenario. Like a normal query string parser should be able to deal with way more concerns than what I'm writing here. Then I can get my query string, and I can try to first split that by this symbol. This means if we have more than one parameter, I have here test, and then test one equal to. So we are talking about, we are getting a string with this value, and we needed to transform that in a key value pair. So that's what we are trying to do here in the simplest way possible. As like that should be with the minimal code as we need. So this is going to break that into an array of name equals value. So now we can map this array, and this array should be able to be broken now by the equal symbol. So I will have some kind of param, and I can return the parent dot split into a equals symbol. Okay, so basically what we have, we start with something like this: test equal abc, and test2 equal 1 2 3. This is how everything looks like in the beginning. After I do this split, I will have something like an array where I have the test equal abc here, and I will deal with this question mark in the beginning later, so probably don't worry about that. And then that the other value we'll have in this array will be the test2 equal 1 2 3. So basically that's what I'm doing here. This first line breaks that into that array. The third line will break that into an array of arrays, where the first value will be test, for example, and then the second value will be abc, and then the second array will have test2, and then string 1 2 3. So this is what this line is doing now. Now, as we have an array of arrays, we can start reducing that or processing that to transform in a key value pair. So I will write here a quick reduce that will be able to get all those entries of arrays and break that into a single object. Let's see here. We can receive some accumulator and some item, and I will return the accumulator. Okay, that's a good way to start. Now we have that accumulator. I can inject as part of this object, I can inject a new key value that will be, the key will be the item position 0, and the value will be item position 1. And yeah, that should be enough to us to process that, because now we would start with this object, and we would start injecting this key value like test as a key, abc as a value, test2 abc, and 1 2 3 as a value. And we may actually immediately return from here, then we don't need to worry about this query string. I prefer to have like some cleaner names in the variable, so that in theory that should work fine. I will actually remove this question mark from the parameters earlier, so then we don't need to worry about that, and then that should be able to give us a clean object to deal with. But yeah, this is the query parser that I am going to use. I will export this, and now we should be able to parse our query string in the other part of in the main function here. So here we can get those objects, we can import our query parser, and now with the query parser created, we will be able to call the query parser with the query string that we have from the browser. And the way we get that is from the location. We have a search object. So the search object is the representation of the parameters, that string with the question mark key equals value. And we are going to send the search to our query string, but you remember that question mark in the beginning. So I'll do a quick slice 1 here only to remove that. And with this, I should be able to have our query object ready to be sent to our root component. That's it. So now we should be able to see in the backend execution the query parameters that we provide, and in the front-end execution the same query parameters we provide. Let's see, do a full rebuild and restart. Yeah, and now if I refresh this page, like you see, I'm providing those parameters to the server side execution, and didn't work. Okay, let's do a test equal this. Yeah, see, now the URL that I provided now was broken and generate an object with exactly that execution. And here we can see if I provide another like name equals testing name, we also have that as part of the execution. So now I can provide as many key value elements to the execution, and that should work fine. And we can try to calculate, yeah, our links here, they are not providing any parameters, but we can calculate it to see if the front-end execution is also working fine. The way I can test that is by changing our menu. And we can, for example, include here in the page 1, I will say value equal 0. That's an let's see how that works. So as I click in the menu, that will be processed only in the front end, but that value equals 0 should also be seen in the page itself. Let's see how that goes. Render, yeah. And now I will refresh this page. Now let's have a look here. So if I have the link, I click on that link, you see that the link provided the value equals 0, and that was processed in the front end side. So this means our query string parser worked. Is still a very naive implementation, doesn't worry about all the concerns that a query string parser should worry, but is something we wrote ourselves, so you should be able to understand exactly how that works. Real project, use a library for that, is simpler. Okay, now that we have this concept of parameters, we can actually start improving our pages and making those pages more functional. Like we can make them do something for us. And you probably already saw I started with this value equals 0 because I have an idea in mind on something that we are going to build. And that is, we are going to transform this page 1 is something like a counter where I can add or remove numbers from that counter. Let me see. To start that, I needed to remove first that query string parser here. I don't want that to be displayed anymore. And as we display the component, you will see here that I have this page component that is the execution of the pages themselves. I will need to make my path and query string available to all the subcomponents, so when they execute, they have access to that information as well. And I will also make the path available to them, because the path can be a multi-level path. So if we have a concept of a deep navigation nested, the sub-pages will need to know which sub-page to render. So that's why I'm going to make all the components to also receive the path and the query, and they can do whatever they want with that. To achieve that, we need to provide here in the types, saying that they receive a path that is a string and they receive a query any, and then becomes kind of optional if they don't use that. That's not a big deal. What we can do now is to go to our component and start using that. So here I will get the path string and the query any. And we can start checking like the information. So as I'm sending the value equals 0, I will be able to retrieve that value from the query. So I can go to my, I can destructure my query. I could destructure the query in the URL itself, but I can also do this here. So if I destructure my query, getting my value, and I should be able to now display that value, something like a value equal and value. So whatever value I provided to that execution, that's what I'm going to see here. Probably we need to deal with the scenarios where the value is not provided, the value is not a number, the value, like there are multiple scenarios to deal with, but let's test this configuration first. And let's see if we are able to display that value in the page 1 correctly. So refreshing here. And yeah, you see value 1. If I navigate to other pages, nothing really displays yet, but value 1 is there. And I can now actually provide whatever value I want. And you see that that displays that. You probably can see where I'm going, what I'm going to do here. Like if we display as part of this component, we display buttons to add or remove values, numbers. That should be an interesting way to deal with this counter. And I can get inspired by the links that we already created here in our menu to do that. So I'm going to copy a link from here, and I will include some links in this page where I can link to the same path where we are now, because I don't want it to deal with that recalculation. So if I link to the same path, but now where value equal 1 or equal value plus 1, I can say need to transform that in a number. By the way, all the values inside of the query string are strings, so you need to transform them in a number first. So what we could do is const number equal value. If I have a value, I want a number of that value. If I don't have a value, assumes 0. That should be a good. Again, this is a very naive. I know that I'm going to call this always with a number, so this number here is not going to be a big deal. And instead of using the value now, I'm going to use this number variable, and we can do here number plus 1. This is going to be our URL, the plus button. That's where the plus is going to link. So I can call here or add a plus symbol, and I can have a minus symbol where I say that number minus 1, and we link in that as a minus, and I change the symbol. So now what I'm doing here is I'm creating HTML links that are able to link to the same page, to the page itself. That's why I point to the same path. But I'm providing the values always with an increment with whatever value I receive, or a decrement of the value I received. And now I'm going to, as I click in those links, I will do a navigation in the page, and I will recalculate that entire page, re-render everything with the new number that I have. That's how I will be able to keep clicking in the plus button and the number should go up, keep clicking in the minus button and the number should go down. And this is a very earlier definition of a state, where we are using the URL and the query parameters as the state of the application. So let's see how things work. Let's see, this should give us some understanding on that state, or at least the beginning. So where the application is still depending on the parameters that the user provided to behave. Like there is nothing that the application do by itself yet. Let's refresh this page. Now we have the value equals 1, and we have here a plus and minus, and they look very close to each other. I will need to deal with that, but I'll try to click here in the plus, and we go to 2, 3, 4, 5, 6. You see the URL there? So when I click on this button, I am actually sending that information to the URL, and I'm actually re-rendering the page with the new number. And that's why I can have this plus and minus working fine. So I don't really have a state coming from the backend yet, because the URL is the state of the application. And if I do force a refresh of the page, you see that I'm calling that page with the correct parameter, value 7. And you will see that I am receiving those two links where the plus link will link to the same page providing value 8, and the minus link is calling the same page providing value 6. So that's why the plus and minus are working, because we have the dynamic generation of those links going to the different numbers. And that should work with basically any number that you provide. You should be able to call that page and go plus and minus anytime. Should be good. Let me split those buttons, make them like more presentable. Again, that's a CSS part would be really interesting to do at some point, because this page looks very ugly. But yeah, that at least breaking into two lines should be better than what we have now. So refresh that page. Yeah, now I have the plus and minus, and I can click on this and click on this. Yeah, good. I think our query parameter part is working fine. We have the page 1 as a demonstration of the query parameter, how that is working. We also could improve our page navigation with the concept of multi-pages. Pages could have like a different sub pages later or something, but I think that we kind of did the routing already. I'll probably skip that concept, because I think we already worked with the routing and the concept of a page navigation. And to deal with sub pages, we would need to deal with the path and the breaking that path in multiple steps. So I will skip that part, because I don't think that is going to be much more than what we saw already, and that will probably be helpful to us to finish the isomorphic topics today. Let's jump into the real thing, the state file. Now, how we can deal with a real state thing. And if you saw my browser here, you saw I had another tab open here with the Star Wars API. So my intention is to be able to consume from this API, get that data, and create a page that is able to display that. Let's go back to the board to explain how that is going to work, as then you will have the context of how things will be. So I wanted to have some kind of page where we have that menu we already have today, the one that is navigating between pages. One of those pages will load this Star Wars display page. So as soon as you access this page, we will have the names of some people there. And to load that people page, we will use this API that is in the screen right now, the /people. As you can see, that generates a result with some people in the list. This API has pagination, but I'm happy with the first page only. So we are going to display the first page here. And then as we click in one of them, then we are going to load their information here, and you will be able to navigate between them as part of that navigation. So this is going to be interesting, because the server will need to consume this API, and will need to make that data available to the client to generate the first rendering. But as we navigate between page to page, the client will also need to load that API to get the extra data that was not originally loaded by the server. That's why this is going to be a very interesting configuration, because we will have a transfer state only for the most necessary data to render the current page, but all the navigation API calls will still need to be done from the front end. And in the front end part, that is going to be a very interesting way when we need to deal with the asynchronous calculation. For context, imagine you are loading, you render a page, and that data doesn't exist yet. So you navigate from one button to another button. You render the application. As you render that, the application triggers an API call, and that API call will take a while to return. So you will render some kind of a loading animation to the user. And when the API returns, then you replace that loading animation to the data that you actually wanted to display. This kind of a process of display an animation and waiting the app to the API call to finish, and as that finishes, you re-render the app, is something we will need to deal. That is probably one of the things that will bring more complexity to our small framework here. But I know a way to make it work. It will look ugly, but it will be good to understand how those processes work. So let's start with that. And we can go into let's look into this API first to understand how that works. So as you can see, we have a possibility of calling this URL, like the Star Wars API /people to get everyone, and then you will get the entire list of people. And you are also able to call that with the position of the ID. So for example, if you get here the first person in the list and you call people/1, then when you do that request, you get only that person, only, in this case, Luke Skywalker. And my computer is not working. Yes, see, people/1, then you get only that person. See? So that's how we are going to do. We are going to do the /people to build the menu, but as you navigate, we call only the people/ the position in the list to get them. And to create that, there are a lot of things we will need to create to support that. The main topic I see immediately is the capability of reading external data. So normally, if you are building only front-end applications, you probably can call like a fetch for an API, and then you get the data. The problem we have here is we are in the isomorphic, so we needed to deal with the data retrieval in the back end, and we needed to deal with the data retrieval in the front end. In each one of those environments, they work differently. So if we can provide some kind of helper function to our common components, so they can call this helper function with the data that they need, and the translation layers would translate to those environments, that would be the ideal scenario. And what I'm thinking is to have some kind of a helper function like called fetch, that we executed the components with the fetch object, and they are able to deal with that on their own. So then we don't need to really, as part of the component, they only needed to trigger that fetch function that we wrote, and that will translate to the environment how to do that. It will make more sense as we go. Let's create that a simple implementation of a fetch function here. I'll create a new file here. I'll call fetch, yes, and this file I will export. Export a function called fetch, and this function is the one that will be responsible to translate all the API calls that my application wants to do to be executed in the server-side way. So the server-side way means we will need to open an HTTP request or to call some API. Normally, if we are going into a real application, you would probably install Axios as an interesting library. One of the interesting points of using Axios as a library is Axios is a red isomorphic, so that should run very well in the front end and back end. But we are going to make things here in a simpler. So the way our fetch is going to work, we are going to receive some kind of URL that is a string, and we are going to call to execute that URL to do something. Our URL may be HTTP or maybe HTTPS. Okay, normally you wouldn't need to deal with that definition, but the API that we are going to use right now is definitely HTTPS only. So to deal with that, I'm going to import the HTTPS helper. So import HTTPS from HTTPS. So that's going to be simpler. If you use the HTTPS with HTTP URL or vice versa, sometimes things don't go very well. And now I can do a HTTPS dot request, and that's how, like a very low level request, that's how it would work. This API, the idea is that this is going to, we would need to wait for a promise or something. So as we executed this request, we wanted to encapsulate that in a promise. So when that is done, we can resolve that promise, and whoever is waiting for that can receive the data that they are waiting for. We could actually start by returning new promise, and that promise can resolve or reject. Very basic promise definition. Then inside of the promise, we are going to start that request. The request is normally going to be only GET request. We don't need to deal with a post to read the Star Wars API, so it should be fine. We are going to read that URL, and that URL will receive the URL, some parameters, and a callback function. This callback function has the response object that we will need later to process the execution. And as we finish the building of this, we need to do a .end. So this .end will tell the HTTPS helper from Node that we finish configuring our request and is ready to be sent. As part of the response execution, we needed to build up all the chunks. Like normally the HTTP implementations, they are able to get fragments of data. As you download those fragments, you can receive them and start processing them earlier. And you needed to build up all those fragments in the end as the final message. Again, we are going very low level in the HTTP implementation to avoid having the libraries or things like that, but this should be easily replaceable by a library, or even Node Fetch would be the same API as the browser fetch. Const, I'll have here the chunks that will be string array, and as I get my response, actually to avoid response, what I have is on data. So this event on data is executed every time we receive a fragment in the response. So as we are downloading, this download, as I said, it could be very, very big, and we get small fragments. So for every fragment that we receive, we wanted to include them in the chunks array. So later we are able to chunk dot to string. We are already stringifying that here, and then basically we have another event that is the on end. That means all the chunks are transferred. So it means everything is already available in the chunks object. And now we should be able to resolve our promise with the final result. So here is where I can resolve with JSON parse. I know that the Star Wars API only returns JSON. If you are dealing with other types of APIs, you don't want to immediately parse that. So resolve JSON parse of chunks.join, and I'm joining with no character in between. So I'm getting a string of an array of strings and joining everything together as a single string and sending that as the resolve of my application. And only as a to simplify, if we get any problems, if I do on error, what I'm going to do, I'm going to reject that with the same message I receive from the on error. So this should be easy. Like if we end up having a problem, like the network has any issue, that will reject the promise and we will see the error message in the console. And yeah, that should be it for, again, a very naive implementation of a fetch API for Node.js. For the browser side, we actually, this part will be simpler in the browser because the fetch already exists in the browser itself. But we will need probably to still wrap that fetch function to have our fetch function, because the native fetch implementation wouldn't require us to do extra things. Like we get the URL, but we needed to fetch, then we have another promise to wait to convert it to JSON and do the JSON parse and everything. So we are going to have a similar function like this in the front end part, and let's do that now here. So I'll create a file called fetch. Yes, and I will export a function fetch. So the idea is to have exactly the same process. We have the same URL string. So as more similar the interfaces of those two functions are, easier will be. But now we think we are in the browser context. So the way to deal with that in the browser would be slightly different, and we would need to call the fetch object of the browser itself. I already called it fetch here. So if I call fetch, the execution will get confused. So I'll go window.fetch. That's the object that I'm going to call with the URL, and we can start dealing with those objects. So I could also make this async, and I can await that fetch to happen. Const result, and then as I have that result, I would do result.json. That is another await, and that will give me the JSON of that result, and I could actually return that, and done. That's the same concept of a fetch, but for the browser part. It's only an encapsulation in a simple consumable promise. Would be simple enough to use. And we would be able now to provide this fetch function to our execution. So here in the index, I can execute the root component with the path name, query, and fetch. We will need definitely to load that fetch function here, because as I don't have anything imported as fetch, the code thinks I'm talking about the native window fetch, but let's import it here. Import fetch. Fetch. Yeah, now we are talking about our implementation of the fetch function. And yeah, definitely. We will need to include that fetch function here. That is going to be a function that receives a URL string and returns a promise of actually the fetch, yeah, returns a promise of any, because that's the API we have. Later we can make a like more descriptive what we have, but then we have the fetch function here, and we will need to include the fetch function in the server side execution as well. And in this part, I will. Yes. Okay. So now I'm giving my front end, my common execution, the common objects. I give them the possibility of triggering HTTP requests. So now, anytime I want a component to deal with that HTTP request part, I can call them with fetch. And the way I'm going to send the fetch object down to the dependencies. And I will also say that this fetch component here is going to be part of the objects that I receive here. Yeah. It's getting a bit bigger here. I can extract the data type, the component in a single interface. I think that would be good to do that. Let me see. I will have some kind of I component, and this should be export interface I component. So my I component object is basically function. Yeah, that would be a type in this case, but is a function that receives those parameters. Yeah, this guy. So I'm actually going to change that to a type. So the component I'll say equal this. So now we have a data component type, and that would be simpler to us to only say here component. Yeah, and then the same this root object would be a component object. So that would be simpler. Then as we update that single interface, that would affect most of it. Okay, now what we have here, we are receiving the fetch object, and we are sending the fetch object down to our dependencies, to our subcomponents. And something we can do now is in our page 2, for example, we can receive a data path, a string, we can receive the query, any, and we can receive our fetch function. Data fetch, I can export page 2 as a component. What I'm doing here, I'm trying to get that component type we just created. Yeah, sorry. Const page 2, it's a component equal this. Yeah, and we can import that component. Yes. So the interesting on doing this is because then I don't need to specify the types of things anymore, because the component type already knows everything, and that would make the code simpler to deal with. So yeah, as you can see, now I only received the path, and TypeScript already knows that's a string, a query, and a fetch object, and we should be able to do a fetch, and it knows that we should provide a string. Yeah, pointing to that area. So now we have some interesting thing, like we are able to load some elements here. So I could call that API there, like the Star Wars API. I'll copy this, and I call that Star Wars API / people, and then, and now we have some type of data with the people here. Let's see, data, and what I'm going to do, I'll do a console log of that data, but I'm not really doing anything yet. I think you can already realize that, like, we are getting to a problem of that asynchronous situation, because when this component renders, we will trigger this execution, But especially in the server side will already return a page that where the data is not there. So we will need to have a way to this server to wait all those asynchronous executions to finish. We will need to populate all that data somewhere and then render the page in the end, not in the beginning. So it's almost like we need a double render. But let's run this content like this to see how things are going to not work. If we see yarn start, at least we should see some API calls, and we should see the data coming back from the server. But okay, we missed something. Let me see. In the fetch.js, cannot find the module fetch.js. Okay. Okay, if you cannot find that module that is in the webpack part, I'm going to move this function here, and we can embed that as part of our framework here. So no need to worry about. Yeah, now you don't need to find any file. Done. Yep, worked. Some configuration in the no. Okay, interesting. Still isomorphic. No, it was in the server part. So the server part didn't find it. Okay, we can do the same. We can load this function here. As part of our file here. I'll load that in the end so we don't do worry about that, and no need to import this fetch anymore. I wanted to have a better file separation, but if the execution is not going to be happy with that, then we add everything the same. Maybe I missed something. Okay, let's try again. We go back to application. We go to the page 2. Refresh. Yeah, you can see here in the console we have a people call. So we did call the Star Wars API from the front end. See, Star Wars API dev/people. We received the data from that result in the front end, and we also had a call to that in the back end. So you see, this JSON in the console is the result of that API call. So we also had a call for that API in this backend. So backend and front end both triggered API calls. But by the time that the data was available, the page was already rendered and visible to the user. So that's the part, the asynchronous part that is complicated. Like you can trigger API calls, but you need to have a way to wait those API calls to finish and then re-render the page as you complete that. And that's the part where a state is very valuable. So a component needs to have some state, so you can change that over time. Like you would be waiting the API to finish, or the API may finish already, or you are presenting a submenu, the submenu is open or closed. Like you needed to have some kind of variables that help the component to know how they should be presented to the users. And some of those variables will be changed based on asynchronous requests. So that's the main problem we have now. We have an asynchronous request, but we don't have a state to organize and wait that asynchronous request to be visible, to re-render the application. So to continue into this process, we will need to have some ways of storing this data. So as those APIs, they are triggered. We triggered the API for the Star Wars API, we get this data. We needed to get this result and we need to store somewhere. So I can safely trigger a new re-render, and this new rendering will be able to get that data and then display an interface to the users. So this place will be the global scope. In our framework here, we are not going to have a scope per object. Normally, React or other applications, they have like Angular has like the component classes to represent components, and they can have their own state internally. We are not going to have a state per object. We are only going to have the global state for the entire application. And for this type of project, that should be simple enough. If I need a state per object, I can always create a subfield inside of the global state to represent the data, and that should be good enough. So now we need to start with that concept of the state. Okay, so we need a state object to treat that. And the way I'm going to do that is by creating a simple const state empty. So this is our state object, okay? And as part of our state object, I will need to call my root function with that state object. So I can say here, hey, here is the state for you. That state may already contain some data, may not contain some data, don't really care, only render that content. And I think to simplify, this is kind of getting a bit clunky, this execution. So I will extract this execution to happen here in the beginning, so I can have the result of that execution, and then I only render the result here. So that's going to do some separation of what we are doing and what we are rendering, because I could even extract this in another function later. But the main point is, as we get to that rendering part, it means don't worry, we finish the execution, and during this process here we may need to wait some things to confirm if the state is populated or not. So extracting that execution here will be good. Now, as I'm providing that state to the component, now we need to make the component aware of that by including the state object. And I think I'm going to convert this object in a component as well, because we are getting, then we can take advantage of the interface I created before. So I have a const root, this is a component, and is equal this guy, and has this. So the good point, now we can simplify a lot of the TypeScript definition here, and I will be able to go directly to the component type that we created before and tell that we now have a new parameter that is going to be the state object. So we have here a component that receives this, receives the fetch, returns a string, and also receives a state that can be anything. Yeah, that's it. So with this, our root component should now know about the state, and we are now forced to send that state to the child element. So I will receive here state, and we need to pipe that state to the child element. So our component now has the visibility of that object, that state object, that is provided by the root component. Now, we will need to deal with the same concept from the front end. So the front end, we will also need a state object that we are going to provide as an execution here to our components. And you probably see what I was talking about as the transferring of the state. We eventually, all the data injected in the state by the backend will need to be visible here to us to use. But as a start point, let's create a similar code where I have an empty state, and I call this component with my empty state here, only to solve the type definition. Okay, going back to the server here. Providing that state on its own is not helpful. I'm going to the component, and I'm going to start using that state. So now we get to a very interesting point where I receive a state object, and this state object may already contain the data I need to display the list of people, or may not contain that list yet. And I think that's the point where we are going to start changing the execution of our component. So we can say state dot people. If I have people in that state, I will return, and let's do a simple page 2, and I will only stringify that list of people for now, only to be simple, only to prove that the data is visible to the user. So JSON dot stringify state dot people. So this is a scenario where that the fetch call that existed down there already finished, already had the data available, and already injected that data in the state. And that's exactly what we need to do if we don't have that data yet. Then that's the case where we are going to trigger our fetch function. And then what we do as the fetch finish, we go to the state dot people, and we inject the data that we need. The data that we need, if we look to the response API, so we have the data, and let me go slash oh. You can see here that that's inside of a results object. So I'm going to already create only the array of results. So I can do like data.results. And so far we should be good to go. You can see that now our fetch, we trigger the fetch, that fetch mutates the state, and then we do something with that. If the state already had the data, then we only display, okay? We are still far away from having this working. This is not going to work yet, but this is a very important step to have the information we need. Let's try to rebuild and rerun that application. And we can see in the browser how things behave. I know that nothing is going to display in the page yet, but now at least we have this concept of a state going all the way through the object. And as I refresh the page, you will see I still have a call to the API. So that means this call to the API is there because the state object was empty. The state that we had in the front end was empty. And that's true because in the front end here, as you can see, I'm always, for every rendering time, I am creating a new state object. So that's why it's always empty. If you see here in the server side, we have this original execution. We have this call here for the result. And the main point is, at this point, after we do that root execution, you can see that our state was empty in the beginning. Okay? We always start with an empty state. We do the root execution. And at this moment, we have the page always rendered as a loading page. Like here, I forgot to write it, loading. So we will always have that page in a loading state when in this moment from the server side. So what we need to do here is somehow identify that the fetch function was called, and we needed to await that to finish. So we have the state populated with all the fields that were necessary, and then we re-render the page again. So in the server side, we will need that double rendering process to be able to fully build the page in the server side with the data there already. And yeah, that's going to take longer. We will render a page to trigger to have all the triggers, and then we render the page again with the final result. The problem we see, there are scenarios where based on the result of one API call, we needed to do another API call, and there is a chain of execution. most of the frameworks, they have ways to identify those dependencies and weight them here. In our framework, we will have only one layer, like you needed to call everything you need from the first execution, populate the state, and have one chance of weighting that. Another thing that we need, so how can we do that? So we needed to kind of identify if the fetch was called, and if the fetch was called, we needed to await those promises to be executed. The way we could do that is I can have some kind of a list, const promises, that will be an array of promises, and I'll say here is a promise array, the promise of any array. Okay, so I have that list of promises that somehow my component execution can populate that list of promises from the fetches or from any other async definitions. And then what we are going to do is I will wait that list of promises to complete. So the list of promises that I have will need to finish somehow to process. So I will have a promise.all promises. Okay, so I will wait all of them to finish. And as they finish, then I can re-render the page with the correct state as the result state. And then the way I'm going to do that is I will trigger a new render inside of this function. That is actually the real rendering. See here that I can actually move this. The first render I'm actually not interested, so I don't really need to save the result. This is the first render is to trigger all the API calls that needs to happen. Then I wait all of them to finish, and then I have the real execution where I'm interested in the result. And then this is the page where we are going to really deal with the rendering part. So what I can do is actually move this entire rendering part inside of this promise and do the result.end there. And the interesting thing is, for some reason, if I have a execution that doesn't have any promise, the promise.all that we are calling here is able to deal with that. Like a promise of all for an empty array is going to immediately execute that second part, and that shouldn't be waiting anything. So now what we need to do is be sure that when we call the fetch function, we actually populate the promises array correctly, and then we can wait that data to be presented. And probably something we could do is to actually provide some kind of a wrapper into the fetch function. I'll call here const fetch wrapper. That will be a simple function. This function will receive exactly the same parameters from the fetch, so it will be a string, and it will return exactly the same fetch object. So this is only a wrapper, a dummy wrapper around the fetch function, but the fetch function returns a promise, right? So then what I can do is get a fetch promise. That is the fetch promise I will return. So I will return the fetch promise, but I can also populate my list of promises with this fetch promise. So what I'm doing here is I'm trying to intercept all the calls to the fetch function in a way that later I can wait all of them in a single placement, and then only when they finish, then I'm going to actually call the rendering of the function. And then now, instead of calling my root execution with the original fetch, I can call with this fetch wrapper that knows how to deal with this object. Probably not ideal, a bit ugly code, but that should be enough to make this server-side rendering process to work. And we can see, like, let's see how that works if we are able to access the server side rendered now with the fetch. Definitely, as soon as we load that in the browser, we may see that for a second, and then the browser is not going to have that access to that data, so it will re-render empty anyway. But let's see how that works now. And that takes a while. See the loading animation? That was not what should have happened. If we received the loading animation, means that the fetch object didn't trigger correctly. Let me see. So let's try to go over the code. We had a empty state here. Then we call the root execution of our project. Let me also, maybe that's not the problem, but let's see. So we have the root execution of the project with an empty state. So that goes all the way to the page 2 component. The page 2 component is going to see that the state is empty, so it's going to trigger the fetch object. This is the fetch wrapper. So we are going to trigger that fetch object. That is going to trigger our fetch wrapper that lives here. So the fetch wrapper is going to call the real fetch, is going to get that promise, is going to push the promise there, and is going to send the promise down to the page 2. So the page 2 is going to be able to wait that fetch and be here waiting for that, and will return the loading page. So that's what we saw rendered there. As we finish that promise, let me see. So we go back, we finish that entire rendering. This is the entire rendering. And then we start awaiting this list of promise. So in theory, the promise that we called the API is here, okay? And then as we finish that, the state object should be mutated because we mutated the state object here. So as a result of that object, we have this mutation. And let me see. I think I know what is because we are waiting the fetch only, not the execution of this part here. This part we are actually not waiting that to happen. So we are probably triggering this execution here before that data actually triggered. And that's interesting to see because that was something resolved in my POC first. See how that was resolved there. Because we had the all promise and that promise, yeah, no, that have resolved. What I'm going to do here is also to wait to that again. This is only because we are already live. I don't want to deeply investigate that promise, so I will create a simple sleep function that will be a function that promise, okay, that will resolve itself. So this promise will have a set timeout. That set timeout resolve in some time. So here I'm going to create here some very simple sleep function here. So we will be able to give a little bit more time to the entire chain of promises to execute. So here, what I'm going to do, I'm going to wait all the promises that triggered the API calls. Then I'm going to give some time to the executions of those promises to do. So I will do a sleep, maybe 100 milliseconds should be enough. And then that should be enough. Yeah, let's see. So dot then so that should be enough. So then I will also, my idea or the understand that I have of the problem is we were able to wait the original fetch promise, but we were not able to wait this dot then. That's why I think we needed to create at least an extra await here. So we are kind of giving some time to those things to work, and we are sending an extra execution to the end of the stack of the JavaScript execution. So by the time we do the second rendering, then the state should be mutated already. That doesn't work, then we have a bigger issue. Let's see. And I should be able to refresh the page. Let's see if things will work. I still see a loading animation. So let me see. Ah, no, wait. Our front end worked too fast. Everything was probably working. But because the front end doesn't have access to this data, it replaced it to the loading. So I got confused with my own. Let's remove this .sleep because I should have checked the server side call in the beginning. Let's see now how things goes. Yeah, everything was working already. So you see, now we are suffering from the problem that I described before, because of that data, the state, the global state object is not sent to the front end. The front end is not able to generate a equal representation of the page the same way as the server side. So that's why things didn't work. Interesting. So the main point we needed to do now is actually make that information available to the page, so everything should be simple. And the main thing that we needed to do, like let's first filter the data that we have, because we don't need this entire results page. So we can map each item into a new object. So it will be a new object where I only needed the name of the person. So item, and I think his name, yes, item.name. And I only needed the index, but the index is already the index in the array. So then I only needed an array of names. Yeah, only an array of names then. So yeah, and our type definition requires parentheses. Interesting. Yeah. So basically we'll get the list of names only and displaying the page. Okay, now we have that state file. The state file means when we run the second rendering in the backend, the state file already had that object populated correctly. Now we needed to make that object visible to our browser execution. And this is the transfer state part. Normally, even if in React, when you have a Redux, this is very common. You would create a script tag where you are going to generate a variable, in my case, state. And I'm using var here because that goes to the browser. I wanted that to run into a wider variety of browser, even the ones without const or things like that. And here, the state is going to be the JSON.stringify of the state object. So the idea is to get the state object and print that as part of the HTML. Let's have a look on how that is going to work. Probably in the final video editing, I'll cut that entire part where I got confused with the backend part, because that's not going to be very helpful. But let's see. So I have the page here. The page now was created with the entire list of names as we wanted. And if we go to the response, we now have here the printing of the state object. As you can see here, we have the script where I have a flag called people and the entire name of people that I had. See? So basically, the state object that was used by the server to generate that page is now visible to the front end. And now we only needed to make the front end use that state. So the way that I have is, instead of using this state object, why not go to the state that is visible in the window object? And I can say window.state. And only to make TypeScript happy, I can declare var state any. So then that should be happy. Oh no, it's not happy. Global. And I will say window as any. So that's the kind of things like in TypeScript. If you in a real project you would create the interface that extends the window to represent the objects that you have there manually, things like that. Here I'm going only to ignore that to simplify, and that is interesting because now I should be able to get that same rendering from the server identical in the browser, because now we have access to the same execution. Yeah, see, now the server side render looks identical to the browser side because the browser has access to the state that was created by the server. Cool. I think we got to an interesting point now. I think this transfer state part was probably one of the areas that is more complicated to understand, and especially when I get confused and I start writing code that is not necessary here, like probably don't need that sleep anymore. And yeah, that's a simple way to us to deal with the transferring of the state and everything. One of the things we don't have yet is our front end is able to render the loading, but is not able to wait and trigger a re-render of the application. So that is something we will need to deal with as to have the front end part more usable. We would have a different end to call the API on its own, especially when we navigate into those sub menus and everything. So what we can do is let's transform this list of names in a menu that we can navigate, and we will be able to actually display the correct data. Probably something we can do is create some links where we have here page 2 where person equal and the index of that person, like person 1, person 2, person 3 as the index of the array. That's probably simple enough. And the index of the array, only to be sure, when we call /people/1 means I'm talking about the position 0 of the array. So I need to get the array and some 1 to display, but we will get to that point. Let's make this as a interesting menu first so we can navigate correctly between those pages. To do that, I'm going to this page, and in this part. So this is the part where we have considering that the state already exists, now I need to generate that menu to navigate, and I'm going to get strongly inspired in our menu object. So I'm actually going to copy this menu, and we can actually create something similar here. So I don't need that there. I'm going to create this, and what we can do here, we can generate based on this object. We can kind of map that element into a list of links or something. So let's see how that's going to look less ugly here. Yeah, should look okay if I do something like this dot map. And then when I map that, I will need to join that with an empty string. Only then we don't display the array there. But then I'll get each person, and then for each person, I will generate a link in this menu. Let's do. I'm going to do something like this. Yep. That's kind of an interesting encapsulation of backticks inside of backticks, but this is for if you have any React experience, you are familiar with this. I'll say a person, that is any, or this is a string, yeah, person name. So we have I'll call actually as a name, and then with this name we are going to say, let's link to slash page 2 where person equal, and then the index of that person. So we need to map the and the same, or actually index plus 1. That's also going to be the URL for the HTML execution in case we don't have JavaScript. And here we are going to display the name of the person. Yeah, that should be good enough. 6 is number, and this looks a bit hard to read. Let's reformat this code so at least we have something readable. Yes, this should generate some kind of menu that we can navigate, and let's see how that works. Yep, that's there, so I can click Luke Skywalker. See, the URL there is changing correctly, so everything is working okay. So I have the same page, and that's working fine. Okay, now we will need to deal with those two executions now. Now we needed to have one API call to deal with the retrieval of the entire menu, and one API call to trigger, or actually we already have the data of the person. So in the state, no, because we filtered to have only the name of only the users there, yes. So to be able to deal with that the other execution here, so we are going to call one API for the list where I have everyone, and if I have anyone selected, I also needed to load the data for that person. I know this API returns everything, but let's try to have a scenario with multiple calls to only to see as a challenge how hard it would be. That's actually not something I prepared before, so it will be nice to see how that is done live, how I can solve that problem. So let's see here. Now I removed that ugly array. I can say person 6, and here we are now loading that information. So I may need to have the person data, because I'll need to populate the state with a new field where we have that information. So I actually have this page needs to be rendered in a couple of different states. Like there is a state where the people array doesn't exist and the person object doesn't exist. There is a potential state where only the people array exists but no person object, and both exist, and then I can render everything. So something like after here I would render that person data like the json.string file, something like that. So let me think how we can deal with that, because if we have that from the server side, if we have any missing data, we will need to trigger all those fetches together. So we needed to trigger the user, the person, and the list all together. So somehow this is no longer like if the people exist, do this or do that. It means if we have any missing data, trigger the fetches for the missing data. If we don't have that missing data, then don't worry about it. And let me see how we can get that. So we will need somehow to get a query. Const, and the query is receiving a parameter called person. So I'm going to extract the person from the query. So that is going to be the ID that I needed to display or not. And that person, the ID of a person may be there or maybe not. I can call this page without a person. And then I still wanted to render the same menu, the same list, but without showing any data here. That would be kind of an entry point. If I have a person, I will definitely need to treat things in a different way. So let's start again. Like, let's try to build all those different states. And I think the simplest one is if I have everything available. Means if state.p is there and state.person is also there. So if I have both entries are in my state object, means I can render this object with both. And the way I'm going to render that is by render the menu we just created plus the element here that will be a JSON.stringify of state.person. Okay, then we display that person, and that's it. And that's actually, that may be a problem because person is not may not be the same as the parameter that I just received. I think we will need to change here. I think it will be simpler if we don't map this object. Imagine we have the entire object here. Why? Because now we only needed to deal with those two states. We only have the people with one list. So look. Yep. Doing in the testing project. So let's keep simple. We are going to have our state object with the entire result of the API. And then what we are going to do is, as I have that element, now I can search inside of that array for that position -1. So I will receive the JSON.string. Oh yeah, but we need a lot of I'll call item, or this is any, then here have the item.name. Now we are talking about the entire object. Here I'm also going to get the state.go in a specific field. I'll say query. Query is a string, so we would need to, not query, person. By the const person index equal. If I have a person, I want a number of that -1. If I don't have a person, then I have an, okay. Then what I'm going to, if I have a person index, then I will render that. So or okay, and then I want to render the person. Okay. Here, let's explain what is going on. So, as you can see, the Star Wars API, when you access the people array, you receive an object that is a complete object with that element. So originally what I was doing was I was extracting only the name, and I was using only the name to display the element. And that made our state object, especially the state that we need to transfer to the browser, very minimal, very, very small. But the problem on that is because now, as I wanted to display the data of the user as well, the person, now I need a secondary API call that will trigger and will get the rest of the data. And the problem on that is normally in a isomorphic that should be simple, that should work fine. But that means that our component would need to trigger those two fetch requests in parallel, get that data, populate the state, the global state, and then transfer that to the browser. So I think we are going to get to that step, but I think it was a too big of a step. So if we can gradually evolve to get there, I think will be simpler. So the strategy I'm going to get to go now is, instead of having that secondary API call, we are going to have a single call that is going to return the entire list. And I'm going to get this entire array as our state object. So then when we display the data of the person itself, I don't need a secondary API call because the data is already there available to me, because I didn't filter that array. So that should be a simpler way to have that working first, and then we can improve that to the next step. Here, so let's see, this should be fine. This should work now. If I probably missed something, so let's see how that's going to work now. And we still didn't have our front end deal, knowing how to deal correctly with those parts. So let's see here. So here I have a page 2. Okay, I'm navigating to that. As I go to page 2, person 1, I click to person 1. Nothing in the front end happen. But if I do a full page refresh, let's see if that's going to happen. And no, didn't render. Let's see what happened. So we called the people, we injected that in this state. Let's have a look what we have in the state object. We have a people, and here, oh, you can see our state object is now way bigger than before. Yes. Well, let's make something here to make it that more readable. I will parse that. Have like normally you would minify everything you wanted to display, but only to make that more readable. Then you will see that entire state object, the entire result of the Star Wars API, was visible in our result here. Oops, early. Yeah. So we can see here now. Yeah, you see the entire object of the Star Wars API is here now. And that's how the front end was able to also render the page exactly the same way. Now let me see, we got a person 1, so we should be able to go to that list, person 1, and start yeah, we need to do some debugging here to see why this was not displayed, because we have the prefix. So let me display the prefix here. Person index, the index. Let's display to see why that was not visible, because it should be. Person, so I'm calling with person, so I have the person, so I transform the person into a number. I do a -1, so then I would go to index 0, and then when I have the index, okay, 0 is false. That's why if I go to number 2 here, then that should work. Yeah, see, we have the person here, because when I provided the parameter 1, 1 minus 1 goes to 0, and 0 is false, and then we don't display that information. So what I can do is actually, the check that we're going to do here is not in the person index, could be in the person object, because then if I have that parameter, then that should be good enough. And or I could say person index different than now, if that would also be a way, because then 0 would be a valid information here. Let's see, now that should work. Simple problems that JavaScript creates. This is one example of the things that TypeScript is helpful on knowing about the nullability or falseability of certain elements, but in this case didn't help us. Let's see, now I should be able to go to the person 1. Yep, and now I should be able to navigate between people here. Yeah, you see how I can navigate between them. In this case, we are not doing an extra API call because the state file that was sent to the front end already have the data of everyone. So now this navigation is happening as a browser only navigation and only displaying the data that already exists in the browser. But we may be able to evolve that and have that API call in the end. So let's see if we can display that now. Now that things are working, we may actually be able to evolve that. And I see we are going very well in this topic. Let me see. Now we have the person, and I wanted to potentially do a new API call for that. So if I have the and the problem is I needed to be sure that I have the person, the state object, the same person as the query string that I have. So if that doesn't match, then no point. Then I needed to trigger the same call anyway. Let me start thinking. So I have this fetch object that goes to the slash people ID, and I have the index. Okay, so if I have the index and I have the object, it's something like a very simple. I'll say slash plus or ID. Okay, so if I have the person parameter or person index is different than now, means I need a person to be loaded. And I'm kind of assuming that if the people object is not there, then the person object is also not there. It's impossible to be there. So then I'm always going to trigger both. So, and then I have here person index, and then I have that data, and then I can inject that in the state object somewhere else in a different area of the object. So I'll say state dot people data, that, and I'll call that as an array. So I needed to initialize that array to be sure that like it may be already there, may not be there. So I'm kind of saying if it's not there, initialize that array, and then what I'm going to do is injecting that data, but in the correct index. Wait, that's not going to work in an array. Let's create as an object. That's going to be easier because then as a key value I can do thing and I can do person indexes. Okay. So as I retrieve the data, I can retrieve the entire list or the list and the person. Let's start testing this concept and see if that brings us somewhere. And I never built this before, so this is coming from my mind now. I didn't prepare this content in advance, so things can go very wrong, and I may need to crop out this part of the video later if that totally doesn't work. Okay, loaded too early, or the server totally died. Yes, the server totally died. Why? We are calling slash. Did we call? Tried to call some API, but it didn't work. I think I know what happens, because when we go, for example, /1, I think we needed to call /1, and there is need to have a slash in the end, so that yeah, maybe we needed to also the final slash. This is ugly. Let's see. Quickly go around the platform. So yeah, good. Yes. Okay. Good. Pause. Okay. Let's have a look if that resolve our problem. And I'm calling 9. 9 may not exist. But, yeah, worked. See, it was the slash in the end. So let's have a look on what we have as part of our object. Oh, we have here people data as an empty object. Empty. That shouldn't be empty. Let's try with a different number here. Yeah, okay. At least the people data is there. So we can see that this code executed. The only part is this didn't execute or didn't have any result. Let me see. Slash oh, if I call 2, means I wanted this. Ah, yeah, in this case, I don't want that to remove 1. So I can use I can actually use the person because I makes sense. And then page people data still empty. Let's try a console list. Something is going on with that. Define. All this in the browser to see what to. /1 slash the yeah, they have worked. So we got undefined as result. So the data dot of course, because there is no result. Now I wanted the data itself. Results was something. Yeah, see the copy and paste problem. Sorry. Now everything should be fine because I'm trying to read a field called results from a JSON that doesn't have a field called results. So yeah, okay. That's the problem of doing things live. And now our data object. Yeah, see, now we have the data object with the right elements. And here you see that this is 1 because this is kind of a representation of accessing an array, not as the right position in the array. So we are that will make more sense later. We may actually have a problems with this numbering, this counter, but so far should be good. So now we do have the data to display the user. So we can start now going back to our rendering here. And instead of reading this from the people array, we can go from the people data array. Okay, so this is where we can get that from. And that should be good. So let's see how that is going to work. Theory, things should work fine. Yeah, things is still rendered correctly. I still got the same C3PO when I call API 2. I know I have a stronger feeling that when I navigate to other links here, things are not going to work. So because data is not going to be triggered. Yeah, see, undefined, because my state object doesn't have that data, and I'm not telling my state object how to deal with that data. So what we need to do here is actually start a process where we don't have the data available. I will need to render a loading or something and then render that correctly. So how we can do that is by checking the and I say if that data exists, okay, good, render it. Let me see. Yes, I can do the same check. So what I can do actually, the const page data equal loading. That's the default data. The default is I'm loading the page. Then if the data exists, instead of displaying the loading, I'll say page data equal y of the page data. So this should be data. Okay, now we can actually display only the page data, and we don't need to worry about this calculation or anything like that. So here it goes. We are getting to the point where we will be able to render the page from the server side with the minimum state file as possible to that data to exist there. And then as we navigate from page to page in the front end will trigger to retrieve the extra data that it needs. So this is trying to get the application to a more realistic point instead of relying only in the state file that was transferred from the server. The front end should also have access to APIs to retrieve data. So that's what we are trying to do here. As I navigated to a page, I should re-render from the server side. Yeah, see, all the data is there. And as I navigate, now instead of receiving undefined, I should receive a loading. Yes. So now there's the moment where we would trigger a loading for that data. We wait a while. So this loading could be an animation or something. And then as that information comes received back, then we re-render the app to trigger everything. So the point we have here is a very interesting, because if we have the data, okay, display. If we don't have the data, now is also a moment where we would need to do a similar data retrieval, similar to what we did here in the full page load. I'll kind of have the same code there. Normally we would have that in a service, we'd trigger that only once, but so far this is okay enough to us to go here. And now, but the point is, now as I retrieve that data, I process and I do the same concept. Okay, what should we do? Okay, this is checking if it's different than now. So in this case, oh yeah, that's not need. So here, the retrieval may be now. The person index may be null. If it's null, I don't want to deal with that, and I don't even need to have the page loading. So page data, let's change that. We will start the page data as empty. Then I will start checking this person now in separate. I need to break the check of the nullability of the person index and the existence of the data, because the nullability of the person index means the parameter to who to display is not available yet. So that's why I wanted to confirm. If this is different than null, means I have someone to display. If this is not true, means I have no one to display and I don't need to do anything because I don't have anyone to display. Okay, now we have the second check, where if I have that person, then I would trigger, I would display. If I don't have the person data, then I trigger the call. See, now I don't have that warning here anymore telling me that the person index is not available. And then what I can do here is, as soon as I check that information not there, then I get the page data to be equal loading. Okay, so if I call the page without any parameters, then I'm not going to load anything, so no need to display that load. And this code is start getting more and more complicated. So let's see how we can simplify that later. But if you follow the entire video step by step, you should be able to follow, because I'm trying to explain what is in my mind as I write the code. And if you are watching offline and you have any questions, write in the comments. I'll be happy to answer that. And if I have the questions before I created the shorter video, I can actually answer them as part of the shorter video as well. Okay, so we should have a interesting process where after this code executes, now we needed to trigger some kind of re-render of the page. Let's test this to see how that works. And we may need to have a new function that will flow all the way to the components to be able to trigger the re-render of the app. But let's see here. We'll do a full page reload from the backend. The scenario that we are talking about is where I don't have any parameters. So if I don't have any parameters, only the menu should be rendered. And we can see here that in this case, our page is very simplistic, like we have only that object. We can now start filtering those objects again because we are not using them to display the content. But we have a very small state file. Now, as I click in the element here, now I should try to call the API, render everything, and trigger that. So let's have it from the server side. That's where the code is visible to us here. So then the server side knows how to deal with that. But I deal with the navigation, and that's not. So the interesting thing I saw here was that when I navigate from this page, I click here, but nothing happens. Why nothing happened? Nothing happened because we trigger a click that re-render the page, but my state doesn't have the person yet. That's true. So we will need to deal with that scenario as well. So we may be rendering a case where I have a person, but I don't have the state, and that's where I trigger this fetch. But browser didn't trigger an API call in that case. Let's see what is going on here. When I was in the page with no menu, means this was null. Okay, so nothing was created, page was rendered, only the menu. We click in that page, we access a specific person. Then we re-render with person. Person, generate a person index. Person index was no longer because we never re-render the page. Yes, true. So we needed to have some way to re-render the page. So you see that as I click here, nothing appear in the page, and nothing appear in the page because we are not re-rendering that after the API call. So this API call is the one that is going to provide the data, and we would need to first render the page with the loading animation, and then render the page again with the data. No, but it doesn't make sense because we would have the person index not now. I'm getting very confused here. That will make this video very hard to edit later. Let's see what we can do here. I'll print the person index here, and let's see what we see on that scenario. Here. No, yes, makes sense because I'm not calling with any parameters. Now as I click on someone, now see I'm calling with a person here. Do we have, see we are having a HTML error. Okay, that's why. So that is coming from page 2 line 55. So some HTML error is happening because we are calling this and cannot read property 3 of undefined. Okay, so undefined, that means that people data is undefined, and that totally makes sense because that object never exists. Okay, yes, so we needed to check if that object exists and contains the object. Done. Now things should work. Yeah, that was interesting because we were clicking and that was not re-rendering. Definitely it was something going on there. Let's test again. Now the page, see, the the person index is null. As I click, I should see the correct person index and the loading animation. And in the network, we should see the call to the person. Okay, now we are in the point where I wanted to be, where we can now start with the concept of triggering a re-render based on the final execution, the finish of the execution of an asynchronous call. So basically, the entire flow, we have the component rendering first, and that component doesn't have the data that it needs. So as part of the rendering trigger, we trigger this fetch function. And then the rendering finishes and display the loading animation. Now the fetch finish will take a while to execute, and will finish and will populate the state file with the correct data. But only populating the state file with the data is not enough. We also needed to trigger a re-render for that, so the data that exists now in the state file could be used in a new rendering process. And the way I want to do that is somehow to call like a render here. And we have the render object in the global scope, right? We could call from there, but I feel is a little bit more elegant if we provide that as a parameter to our code. So then we don't rely on that call, because remember, we are in isomorphic. The render object doesn't exist in the global scope, the server side. The server side doesn't have a render in the global scope. So that's why we will need to provide that as a call to the function itself. So let's go back. Let's say our component now needs to receive also a render function that will be a function that returns void. So it's a very simple function. Provide. Now with that, a lot of things break. So I wanted to receive the render function. Provide that function. Yeah, and now we needed to provide that render function from both environments. Let's have a look here. Let's start with the backend. What could be our render function in the server side? And I think server side, like the concept of a re-rendering is actually not really necessary. We could provide like a dummy function, a function that actually doesn't do anything, because in the server side, calling the re-render is not necessary. Like the main point is server side will wait all those promises to finish anyway. So that's why there is no need to have a re-render there. And we are going to provide like a nope function, doesn't do anything, because for us in the server side that's relevant, but it's good to have that function so the interface of our components are identical. Then in the front end, we are going to provide the render function, and the render function can actually be the same render function that we already have. So if I do render, that should be enough. And now we are giving the ability to our components to trigger a full re-render of the page. So let's use that ability in the end of the execution of our process. One of the interesting things, we are only doing this manual trigger of a re-render because this is a very simple framework. Most of the frameworks, they know how to trigger a re-render as you mutate the state. One example is React. As you set any object in the state, React knows to trigger the re-render to apply the changes from that state in the page. But we don't have that, or we don't have anything listening to our state to trigger that magically. So that's why we needed to trigger that re-render ourselves. And the way we do that is by getting that function that we made available all the way from the top execution, and I call render. Cool. That should be an interesting point where we should have a application working now, consuming from API from the backend and from the front end part. Let's have a look now. Let's do a full page reload here from our home page. So let's do a full overview of the entire application now, because I believe that should be working fine. Page 1 was where we created the data plus and minus, like it's a counter, and that is actually only using the query string as a state to manage what to display. Page 2 is where we created the concept of the page, and the original page was not loaded. Ah, yes, we missed one trigger in the re-render part. Here. As we do this, we need to render as well. That's why that call didn't work. Okay. Cool. Let's see now. Early? Yes. Okay. So if I go here to home and refreshing the home page, why is important to refresh the home page? Because then our state file completely empty. So there is no need for a state file to render the home page. So all the data will be triggered by the front end now in this example. Then we go page 2. We show the loading. The loading was displayed as a result of the rendering of this loading page here. But that triggered this execution here. And then as the people array was visible, we re-render the page and then we display the menu. And now I can click in a person here. I can load and display. See, now I have a full front-end application that is able to load the data here from the front end. And as I force the refresh of this page should come from the back end complete with all the data that we had, including people data and the list of arrays. So let's filter this array again to have only the names. Now that we only need the names, no need to transfer so much data. And now our application actually gets very specific on the state that we're transferring, like only the minimal state possible transferred to the browser. Let's filter that again. So here we have this result, and I will map that. Name. We don't need that. This item, yeah, I don't care. And now that we have item.name, this is an array of strings. So when we get this here, we are going to say this item, the string, fine. And here we go. That should be enough to simplify the amount of the size of the state we need to transfer. And now we have a full working application. Even if we turn off JavaScript, we have this application fully working. I'll disable JavaScript. Let's see, go to the home page. Like I can go to this plus and minus. You can see that this plus and minus is working because I have the full page reload. See? And I can also go to the page 2, where that is going to load this menu or load the menu with the content. See? And that now, without the JavaScript, everything still works because I'm doing the full page reload and my server side knows how to handle those two things. Now, if I add JavaScript again, now I can do the same navigation and you can see, oh yeah, reloaded the page. Now I can go see. Now I only loaded the JSON that is that fragment of data. I don't need to load everything. And as I slowly populate the state of my browser, if I go back to the page I loaded before, I don't need to load that API again. See, the state object is already there, so I don't need to load that data again. And yeah, that's how we get the minimal size for our state as possible. See, the list of people now is basically only a list of the names, and I have only the person that I am displaying coming from the server side, and over time I can actually include even more people there. Let's have a look in our state. Now that I navigate into multiple objects, let's see what the state looks like in the browser side. So over time I got a part of this object came from the server in the very original execution, and then as I navigate in the pages in the front end, I had more API calls to increment even more the data there. So now I have way more people data there, but the list of names are still the same, you see? So only one of these entries in this object actually came from the backend. Everything else was populated in the browser. And I think we took a long time today. I was also skipping the CSS part. I think we got to a very interesting working state here, where we have a fully working API browser that is fully isomorphic. And probably we can complete our isomorphic concepts here. This project wouldn't be too hard to also start having some forms, submitting some data, having some extra things like that. Wouldn't be too hard. I'll push the changes we just made here to GitHub as well, and yeah, probably in a couple of days I will create the shorter version of this live stream that will be included in the live stream playlist in YouTube. And that should be an interesting topic to share with people. I'll try to cut out the parts we diverge from the main topic here, because there was a lot of distractions and things that I thought were not working, and we started dealing with some different issues here. But after finding everything, I think the video will be cropped in a way smaller version. And yeah, if there is any other topics, we probably are getting close to the end here. If you have questions, please write in the chat right now. I think we are going very well. There is some people watching on YouTube. There are some people watching other platforms as well. That's very cool. And let's look like no other questions. Again, thank you for the support. Next weekend we are going to start talking about security, having some applications to demonstrate how those HTTP headers, especially CSP3, was very interesting. I'm very happy on the evolution of the CSP and how we can now get some more interesting ways to allow or block certain resources in the page. We can cover those things in the next weekend. And yeah, thank you again for your support. Yeah.